Good morning, students. In the last video, I did videos regarding the engineering drawing, and around 57 videos are there, and it covers the total first year BTech engineering drawing syllabus. Right? Now, in the second semester of first year, there is thermodynamics subject. Okay? Related to the thermodynamics subject, now I would like to do the videos, and this will be broadcasted in YouTube so that every student can benefit out of it. Now I will start the thermodynamics, right? Now in the thermodynamics, first we need to think what is thermodynamics. Thermodynamics is an axiometric subject which deals with the work and thermal energy or heat energy. It is an axiometric subject which deals with heat energy and work. What is axiometric? Axiometric means a subject which develops based on some theorems or some laws. Then we can say that is an axiometric subject. Okay, here in the thermodynamics, one can observe zeroth law of thermodynamics, first law of thermodynamics, second law of thermodynamics, and third law of thermodynamics. These four laws basically governs the entire subject. Okay, and the zeroth law of thermodynamics, it deals with the concept of temperature. It gives a property of temperature, right? And first law of thermodynamics, it is a law of conservation of heat and work energy. Okay, law of conservation of energy, and it says that heat and work are mutually convertible, and it gives a property of internal energy. Next, second law of thermodynamics, it deals with a directional law. That means where to where heat can be flow, and it deals with quality of heat energy. That means how much heat energy that can be converted into work. Okay, it gives the property of entropy. Next one, the third law of thermodynamics deals with absolute zero temperature. Absolute zero temperature, the entropy is zero. Okay, likewise these four laws, those will governs the entire subject thermodynamics. That is the reason thermodynamic subject is called as axiometric subject. Okay, next, second one, it deals with heat and work. Now come to the title of thermodynamics. The thermodynamics title itself, it shows that thermo plus dynamics. Thermo related with thermal energy, dynamics deals with the motion. That means whenever a force is applied on a body and the body is displaced in the direction of applied force, work said to be done. Okay, that means the displacement which is occurred due to the heat energy, we can say that is the work. Okay, therefore heat and work are mutually convertible, as well as this subject deals with how much heat energy can be converted into work. Okay, how much, what is the efficiency of conversion? Likewise, that is the reason the thermodynamics is the subject which deals with the heat and work. Okay, now once again students, please note the definition of thermodynamics. Thermodynamics is axiometric subject which deals with the heat and work. Right. Now, strictly speaking, thermodynamics is a part of thermal engineering. Thermodynamics is a part of thermal engineering. Now we will see. Suppose if you consider thermal engineering The thermal engineering can be divided into first one, thermodynamics, applied thermodynamics, right? The third one is heat transfer. Okay, in the thermal engineering, basically thermodynamics, applied thermodynamics, and heat transfer. Right. In the thermodynamics, we will see the mathematical relations. Mathematical relations by considering different thermodynamic processes. It may be constant volume process, constant pressure process, constant temperature process, adiabatic process, throttling process, free expansion process, likewise. Okay. The thermodynamics deals with different mathematical relations related to the processes, the mathematical relations related to the cycles, the mathematical relations related to the different applications, okay, the mathematical relations related to the entropy and convertibility of heat energy into useful work, reversibility, and the properties of steam or pure substances and compressible flow. That means different types of flows. Okay, these are all comes under the thermodynamics, right? That means the fundamentals related to the applied thermodynamics are covered in the thermodynamics. Now come to applied thermodynamics. What is applied thermodynamics? The application of thermodynamic properties or thermodynamic principles, the application of thermodynamics in the realistic situation and designing of a system is called as applied thermodynamics. Okay, this is a boiler, and you know what is the function of a boiler. Boiler is meant for generation of steam. Okay, that means we will send water inside and we supply heat energy Q to the boiler. After that, the boiler generates steam. Okay, and here superheated steam, high quality steam we will consider. Therefore, here the steam. After that high quality steam that will enter into the nozzle. This is the symbol for the nozzle, convergent divergent nozzle. Okay, this is the symbol for the boiler. Okay, now it is enter into the nozzle. After that, a high velocity jet comes out of the nozzle. Okay, after that high velocity jet, it is enter into the turbine unit. This is the symbol for the turbine unit. In the turbine unit, expansion of steam will be there. That is the reason this is the smaller length, this is the longer. Okay, and this is a turbine unit. Turbine. Okay, after the turbine, due to the high velocity jet work done over the rotor of the turbine unit, then it causes for rotation of a electrical generator and it generates the electric power, right? After that, low enthalpy steam come out of it. After that, this low enthalpy steam is entered into a condenser. Okay, this is cool water in, cool water in, cool water out, and this is the symbol for condenser. right? Condenser, right? Condenser. After that, the condensate which is comes out of it, it will enter into a feed pump, and from the feed pump again the water is condensate enter into the boiler, and the cycle is continued. Okay, that means here the boiler and related principles, everything we can study in the thermodynamics. Nozzle related we can study. The turbine independent units we can study in the thermodynamics. After collectively we can use the in the realistic application, and respect to efficiencies of individual components as well as a whole to work a power plant we can calculate the efficiencies. Because such type of applications will be there in applied thermodynamics. That means working of IC engines, working of gas turbine, working of refrigeration systems, working of air compressors. Okay, likewise, wherever the heat energy is involved and some machine is designed, it comes under applied thermodynamics. It comes under applied thermodynamics. Right. Now come to the third portion of heat transfer, portion of thermal engineering, that is heat transfer. In the heat transfer, we know the heat is transferred from one body to another body in the form of conduction, convection and radiation. Okay, in these three forms only the heat is transferred. But while transferring the heat energy, there is no work done. Okay, pure heat will be transferred and mass transfer will be there. Okay, now the heat transfer is the subject which deals with the transfer of heat energy from one place to another place or one body to another body without doing any work, but purely due to the temperature difference. Okay, then it will be heat transfer subject, and in the heat transfer also condensers. Here there only heat transfer it is there, and types of boiling, evaporators. Okay, these are all we will study in the heat transfer subject. Okay, now we will restrict our ideas up to thermodynamics only. Now we will see here from the previous discussions what we concluded, thermodynamics is the subject which deals with the basic mathematical equations related to applied thermodynamics or different components, thermal engineering components. Okay, therefore each component in the thermal engineering we can consider as a system. Okay, and wherever some thermal energy transfer is there, we can call that as the system. Okay, now we come to the concept of system. Okay, before going to the concept of system also, I want to tell in the thermodynamics, this is the subject deal with many engineering branches. In the chemical engineering also thermodynamics is there. Okay, mechanical engineering also thermodynamics is there. What is the difference? Here in the thermodynamics, two portions we can divide. One is microscopic thermodynamics and macroscopic thermodynamics. Micro and macro. Microscopic and macroscopic thermodynamics. That means if we consider pure substance, or if you consider any substance, it consists of molecules. If you go up to the level of molecules and how the thermal transformations are there, how the heat energy is moving or how the work is performing, how the reactions are going on. If we study up to the molecular level, then it will called as microscopic thermodynamics. In the microscopic thermodynamics, individual particle movement we consider. Okay, and most of the times the chemical engineering students are deal with microscopic thermodynamics. Now come to macroscopic thermodynamics. What is macroscopic thermodynamics? In the macroscopic thermodynamics, a concept of continuum we will consider. That means we will consider collectively some matter as one unit, and that matter is the continuous matter, and the collective properties of all molecules for that matter considered as one unit. Okay, that means the collective properties we will consider and we will perform. Okay, we are not considering up to molecular level. Okay, up to molecular level we cannot consider, right? But we consider all some portion, and that portion, the total molecules existed is continuous we consider, and that portion is a single unit, or that portion as a whole we can consider as a system, and we study the respective properties. Okay, and respect to mathematical relations or thermodynamic relations. Therefore, that is called as macroscopic thermodynamics. In the mechanical engineering related thermodynamics, we come across macroscopic approach only. Okay, not microscopic, macroscopic approach. And the macroscopic thermodynamics also called as classical thermodynamics. Okay, now we will see the basics of thermodynamics, right? Now here, if you want to study boiler, we want to take it as one system, and we want to study the boiler performance, okay, and boiler related equations. Suppose if you want to study the nozzle, we want to consider nozzle as one system, okay, and we can study. After that, if you want to study the turbine as one system, where heat input, where work output, likewise. And if you want to study the condenser is one system, okay. Here, every time I am using the term system, okay? And now we need to define what is a thermodynamic system, right? Now, note down thermodynamic system. What is a thermodynamic system? Thermodynamic system can be defined as a region in the space where thermodynamic processes takes place. Once again I repeat the definition, please note it. A region in the space where a thermodynamic process takes place, we call it as a thermodynamic system, right? Now, for this thermodynamic system, we will consider one example. Suppose if you go for a computer lab. Inside the computer lab, different systems are placed inside, and students are sit in front of the systems, and the computer lab totally covered with walls, okay. Then if we want to study how the heat interactions in the computer lab, if you want to study the up to the boundaries of the computer lab, up to the walls of computer lab, we need to consider as one system. And computers are heat generating units, and human beings are heat generating units, and fans which are provided in the lab, heat generating units. lights which are provided in the computer lab, heat generating units. Okay, now the generated heat, it will be crossing the walls of the computer lab, and it may transfer to the surroundings. At the same time, from the surroundings also heat may enter into the computer lab. Okay, that means if we want to study the computer lab, we consider computer lab as one system. Okay, and here the computer lab inside is a system, and the boundaries, walls of the computer lab, we can call it as boundary of the system, and the things which are outside the boundary are called as surroundings. Right? We will see one more example. Suppose if you consider a glass of water, okay, the water considered as hot water. If you consider a glass of water and it is hot water, okay, due to the high temperature, the heat will transfer to walls of the glass. After that, it will transfer to the outside environment. Okay, right. Now, the heat transfer is occurred in between this system to surroundings across the boundary. Okay, and this one is the boundary of the glass system, and this is the system, and this is the boundary of the system, and outside the boundary, that is surroundings. Okay, now the student may ask one question at this juncture. Here, is the boundary of thermodynamic system is constant? Is the boundary of the thermodynamic system is constant? No. Boundary is an imaginary boundary, imaginary line, imaginary surface. Okay? It is an imaginary one and which separates surroundings and system. Right? Now, note down the boundary of the system. The boundary of the system. The imaginary line or imaginary surface in between system and surroundings is known as boundary of the system. The boundary of the system separates the system and the surroundings, right? And system and surrounding collectively we can call it as universe. System and surroundings collectively we can call it as universe. Right? We come across the definitions of system. We come across the definition of boundary and universe. Now we will see boundary of a cylinder and piston. Now we want to study the gas which is at this portion. Okay, this portion is filled with the gas. Right. Okay, we want to study the thermodynamics of this portion. Okay, right. And this is piston, this is connecting rod, this is cylinder, and it is connected to a crank. Okay, it is connected to a crank. Right. Now, initial stage, this is the stage 1, we can assume. Okay, at this portion, this is the boundary. Right? Suppose the hot body comes into the contact with the air, then it will cause it for expansion. When it expands, the piston is moving downwards. Okay? suppose the piston moves up to this portion, right? This is the position now, right? When it moves down, the boundary, what we consider, up to this we need to consider, right? That means the boundary is imaginary one. According to the system, it may enlarge and contract like this. Okay? It will not be a constant one. Okay? This we need to identify. Next one. Suppose if you consider a flow system. For the flow system, you can consider turbine. Into the turbine, the steam at higher enthalpy is entering. Okay? And the steam at lower enthalpy it is leaving. Okay? Next one, the work delivered to the generator. Okay? Therefore, the heat interaction is there, work interaction is there. Okay? But the boundary, it remains constant. But that means we consider a constant boundaries or a particular volume for the turbine. Into that volume, how much amount of heat energy is entering and how much amount of heat energy is leaving, how much amount of heat energy is retained inside, okay, how it is diffused inside the control volume, okay, and how the work is come out of it. Okay, we consider like that. That means the same boundaries with constant surface, control surfaces, if you consider for a flow system, the system can be called as a control volume, CV, control volume. Okay, control volume. Control volume, when it will be called as a control volume. Suppose this is the Q and into this Q heat or flux entering and some of the flux is diffused there and some of the energy is retained there. After that the remaining one is come out of it. Okay, and work may be supplied here and the work, some of the work is utilized inside the control volume and some of the work come out of it. Okay, that means the work with respect to the work and with respect to the heat or flux, okay, the control volume, the dimensions are not changed. Okay, it is remains constant, but it is flowing. That means it is a flow system. Okay, it is a flow system. In the flow systems, if you consider the volumes like this, then it will called as control volume. And respective surfaces are control surfaces. These are all control surfaces. Okay, note down control volume. Okay, if you consider a system boundaries fixed for a flow systems, then we can call that as the control volume. In the control volume, its dimensions remains constant, and into the control volume, the mass or flux is entering and leaving, and into the control volume, work is entering and leaving. Okay, and inside the control volume, whatever be the phenomena are happened, you will study. Okay, therefore such type of system is called as control volume, and respective boundaries are called as control surfaces. Right? Okay, now what are the different systems generally we will see in the thermodynamics, we will discuss now. basically we consider. First one is open system. Open system. This is the first one. What is open system? It is open system, closed system, isolated system. These systems are divided by considering energy and mass transformations. Okay, with respect to mass and energy transformations, three system classifications are there. First one is open system. Suppose if you consider this is the system, this is a system, and into the system, this is the line which indicates mass, this is the line which indicates heat energy. Okay, M for mass, Q for heat energy. Now from the system, this is leaving and this is Q leaving, right? Suppose mass and heat energy, both are entering into the system and leaving from the system, then such system is called as open system. Okay, mass is entering, mass is leaving, heat is entering and heat is leaving. Okay, such system is called as open system. Okay, for the open system you can consider the boiler. If you consider the boiler, see, if you consider the boiler, heat entering into the system along with the water, the heat energy come out, mass, water entering into the system. Okay, after that due to the receiving heat energy in the form of vapor, the mass also comes out of the system. Therefore, mass and heat energy entering, mass and heat energy come out of the system. Therefore, it is an open system, right? Examples for open system. First one is boiler. The second one, turbine. Next, air compressor. Air compressor. Likewise, different instruments are there, different devices are there. Okay, the students need to list out whether mass and heat is crossing the boundary or not. Okay, this is the open system. Now come to the closed system. Second one is the closed system. Closed system. Suppose a system like this. Now you can draw mass, heat, mass, heat. Okay? Only energy interaction is there, but there is no mass transfer. Only heat entering, heat leaving is there, but there is no mass leaving and mass entering. Such type of system is called as a closed system. That means heat enters, heat leaves, but mass will not enter, mass will not leave. Okay? Such type of system we can call as the closed system. Now you may observe such type of system. Consider a cylinder and piston. Here, this is thermodynamic adiabatic valve. This is adiabatic valve. That means there is no heat interaction from surrounding to system or system to surrounding. Right. This is only the diabatic valve. That means heat entering is allowed. right? And this is the piston, and this is the connecting rod, okay? And a perfect gas inside, right? Now, when heat supplied to the perfect gas, the gas will expand and piston will move downward. Once it is reaches the extremely bottom portion or bottom dead center, when cold body when it is comes into contact, the heat energy possessed by the perfect gas will be leave out and it will contract. The piston will move in upward direction. Okay, again heat body contact, it will come down. Cold body contact will move up. Okay, that means here only energy interaction is there. Same mass, it is repeatedly it is working there. It will not cross the boundary. Okay, only energy interaction is there, but there is no mass interaction. Okay, such type of system is called as a closed system. Okay, particularly examples for the closed system are internal combustion engine. Right. Now the third type of system is an isolated system. The third type of system is an isolated system. Okay. Third one. Isolated system. Now, what is an isolated system? Neither mass nor heat energy is crossing the system, then we can call that as the isolated system. Neither mass nor heat energy crossing this boundaries of the system is called as a isolated system. See, this is mass, this is heat energy. This is mass, this is heat energy. Neither mass is not entering, mass is not leaving. Heat energy not entering, heat energy not leaving. Okay, into the system. Then that system is called as a isolated system. Okay. Examples for the isolated system. For best one is the thermos flask. Thermos flask. ఓకే మన ఫ్లాస్క్ తీసుకుంటాం. ఫ్లాస్క్లో హాట్ వాటర్ వేస్తాం అనుకోండి. ఇఫ్ యూ క్లోజ్ ద లిడ్, ఓకే, బౌండరీస్ ఆర్ థర్మల్లీ ఇన్సులేటెడ్. Okay, there is no heat transfer from the system to surroundings or surrounding to system. Okay, therefore mass transfer also be not there, and therefore the quantity of water which is poured in remains same. The heat energy also remains same. Okay, hot condition less than hot condition alage untundi. Okay, therefore the isolated system best example is thermos flask. Another example for the isolated system is universe. Okay, here universe means a collective amount of system and surroundings. Okay, wherever the heat or mass interactions are there, system to surrounding or surrounding to system, the heat and mass, okay, that may be transferred, but we consider it as a whole as one system. Okay, universe means as a whole, system and surroundings collectively we consider as one unit. Okay, one system. Therefore, that is isolated system. Universe also another example for the universe. Also another example for the isolated system. Okay, here just definitions I explained, and the important matter only I written over the board. But student, the definitions also you need to write in the notebook clearly, so that your own notes will prepare in your notebook. Right. These three systems, by considering different phases In the respective matter, we can consider that as a homogeneous system and a heterogeneous system. Suppose the total matter is uniform and it is in single phase, we can call it a homogeneous system. Or different phases are existed in a system or in a matter, then we can call that as heterogeneous system. Example for homogeneous system, air. Air, even though it is having nitrogen, oxygen and some of the inert gases, these are mixed and it mixed in a homogeneous manner and uniformity is there, then we can call that as the homogeneous mixture. Suppose if you consider superheated vapor, okay, all water it is converted into superheated vapor, it is a homogeneous mixture. Or if it is in the form of water, homogeneous mixture, okay. But the combination of water and ice, water and vapor, ice and vapor, if it is like that, even though the matter is same, the phase is different. In such cases, it is called as a heterogeneous system, right? Okay, now up to this we learn in the first class, right? Before concluding the class, I want to summarize what we learn in the class. Okay, first we start what is thermodynamics, and we studied that thermodynamics is a part of thermal engineering. After that, with an example, what is the applications of thermodynamics we saw. Okay, after that we go for the what is system and what are the different systems are adjusted, how the boundary is, okay, what is control volume, okay, and heterogeneous and homogeneous systems. These we learn in this class. Thank you.